Welcome to solverfy.
Right, so to see if the numbers verify the Collat's conjecture, or the 3x plus 1 conjecture, one follows the steps quite algorithmically. So starting off with 16, you see that 16 is, all right, so you first divide by 2, that's 8. 8 divided by 2, that's 4. 4 divided by 2, that's 2. And then 2 divided by 2, that's 1. And notice that as soon as you have a number which is 2 to the power of n, that number is even. And you basically divide by 2, that gives you 2 to the power of n minus 1. And so you can, by recurrence, show that you will necessarily take an exponent away at each step, and you'll end up with 1. Okay, so you know that as soon as you hit the power of 2, that you will end up at 1. Okay, so that solves A. That was quite quick. Now for question B, start off with 11. Multiply by 3 and add 1 gives you 34. Then divide by 2, that gives you 17. Then multiply by 3 and add 1 gives you 52. Divide by 2, that's 26. Divide again by 2, that's 13. Then 39 plus 1, 40. Sorry, 40 here. Divide by 2, 20. Divide by 2, that's 10. Divide again by 2, that's 5. And then you multiply by 3 and add 1 gives you 16. And notice that at this point you end up at the same point you are in A. And so you know that you will end up at 1. Okay, so use what you found in previous exercises. Can make the chain faster. Now, if you start at 35, multiply by 3 and add 1 gives you 106. And so by now, this is quite, you should get the gist. But then, so at 160 divided by 2, that's 80. And then divide by 2, that's 40. And there again, notice that you already have 40 in this chain. So necessarily, if you hit 40, then the chain will be identical as the previous one. And therefore, you will attain 1. Okay? And so if you attain 1, then you go to 4, 2, 1, 4, 2, 1, 4, 2, 1, which is the whole point of the 3x plus 1 conjecture, right? And so for the last number, you are at 113. Multiply by 3 and add 1 gives you 340. And yeah, you repeat the process. Divide by 2, then divide by 2 again, you're at 85. And then 256. And here, notice that 256 is 2 to the power of 8. If, yeah, I think that's it. Yes. 2 to the power of 8. And as I've said before, once you hit a number which is a power of 2, which is the case here, you will end up just by dividing 2 until you reach 1, you will end up at number 1. Okay, and that's why, I mean, knowing, just in general, knowing the powers of 2 is quite useful, especially, for instance, in computer science with binary numbers, etc. Okay,